Hello student. In our previous lecture we will discuss about the separation of amino acids at their isoelectric point. Now the second most important topic in ion exchange chromatography is separation of different metal ions by using ion exchange resin. So these metal ions can be separated by using a different complexing agent to convert this metal cation into its anionic form or complexes, and these complexes can be separated or isolated by using anion exchange resin. Let us see. Many metal ions can separated on anion exchange resin by converting them into anion complexes, anionic complexes. The complexing agents like chloride, bromide, fluoride, etc. The uncharged complexing agent also affected the equilibrium if they forms a complex that dissociate before the metal can exchange or complexes can exchange in the resin. If they changes its size, many complexing agent are either weak acid or bases or salt of this. So we can form at least a complexes having a stability that cannot be dissociated before the exchange. For successful separation of metal ions on the anion exchange resin or column, a complexing acids are added in a high concentration. That means to form a stable anionic complexes with metal. For example, concentration of hydrochloric acid forms anionic chlorocomplexes with all common metals with exceptional alkali and alkaline earth metal and aluminum, nickel and chromium. But out of other or all are forms of chlorocomplexes with quite stability. The anionic complex formed can be adsorbed on a quaternary ammonium anion exchange column. That means on a strong anion exchange resin. The separation of many metals can be carried out by using a Dovex 1 anion exchange resin as a function of concentration of HCl, and it is depend upon distribution coefficient of different valences of metal. Separation of metal can be achieved by choosing HCl concentration at which one element has high distribution coefficient and other element have low distribution coefficient. The complexes with high distribution coefficient will strongly retain in a stationary phase, while the element with low distribution coefficient will be eluted first. Accordingly, we can able to separate different metal ions. It is in the anionic complex form. Then by decreasing the HCl to the level at which distribution coefficient of second metal is low, the metal can be eluted. Several metals ions can be successfully eluted in this manner by changing the concentration of complexing reagent, that is HCl. For example, the mixture of several metals, for example, nickel plus 2, Mn plus 2, cobalt plus 2, copper plus 2, Fe plus 2 and Zn plus 2. Suppose this is the mixture of metal ions, so that will be separated accordingly by changing the concentration of complexing reagent, that is HCl or hydrochloric acid. So let us see how it is change the distribution coefficient by changing the concentration of HCl. The Ni plus 2 do not form an ionic complex, and thus it is diluted first by 12 molar HCl. That means if we add 12 mole HCl, then other than Ni plus 2, they forms a complex, then they will be written in the stationary phase and Ni plus can be eluted first at concentration of 12 molar HCl. So if we change the concentration, then Mn plus 2 is essentially not adsorbed in 6 molar HCl, while other metal ions strongly retained by the resin. Hence, Mn plus 2 is eluted at 6 molar HCl. That means if we move from 12 molar HCl to 6 molar, so other metal ion form complexes and retain in the stationary phase. So Mn plus will not be adsorbed, so it will be eluted at 6 molar HCl. That means at 12 molar Ni plus to be separated, at 6 molar Mn plus 2 will be separated. Then again if we change the concentration of HCl, that is at 4 molar HCl, the distribution coefficient of cobalt plus 2 is very low, and hence it is eluted at 4 molar HCl, and other complexes having high distribution ratio, so that will be retained in the stationary phase. If we again change the concentration of HCl, that is at 2.5 molar HCl, Cu plus 2 is eluted because distribution ratio of Cu plus 2 HCl complexes is very low. That means at 2.5 Cu plus 2 is easily separated. Again we can change the concentration of HCl at 0.5 molar HCl. The distribution ratio of Fe is unity or very low, hence it can be eluted at 0.5 molar HCl. And finally, Zn plus 2 is strongly adsorbed, that can be acid concentration decreases up to the 0.005 molar HCl, then it can be eluted at very low concentration of HCl by passing several volume of mobile phase continuously, because Zn plus 2 will be retained strongly in the anion exchange region. So in this way we can easily separate these metal ions by changing the concentration of HCl. So in this way we can separate the metal ions by using an ion exchange resin. So last is the application part of the ion exchange chromatography. So ion exchange chromatography is very important chromatography because it can be separated, isolated or quantify or purify the polar molecules, polar biological molecules or metal ions or charged molecule. So let us see one by one application. First application, it is an important use of ion exchange chromatography is that in routine analysis of amino acid mixtures in different laboratories. The 20 principal amino acids from the blood serum or from hydrolysis of proteins present in our body can easily separated or identified by using a clinical diagnosis by using ion exchange chromatography. To determine the base composition of nucleic acids, DNA, RNA, bases present in the nucleic acid that can be identified or purified. For example, adenine, thymine, guanine and cytosine. These are the bases present in the nucleic acids. It is also used for the separation of many vitamins, other amines and organic acids and bases. It is also used for purification and separation of metal ions from their mixture that we already discussed. This is most effective method for water purification. Complete deionization of water can be possible or performed by the ion exchange chromatography. So we can say a softening of drinking water. We can in every house we can now use as a soft water for drinking purpose, or we can use this ion exchange resins for the purification of water or softening of water in water purifiers. Next application, in the analysis of product hydrolysis of nucleic acids. In this way, it gives the information and structure of these molecules and how it related to their biological functions, as carries the hereditary information from one generation to next generation. Chelating resins are used to collect traces of metal from the seawater. It is also used to analyze lunar rocks and rare traces elements present in the earth crust. It is also used, ion exchange chromatography also find an application for the analysis and separation of lanthanides, actinides and noble metals like gold, silver, platinum, etc. Here we finish the fourth chapter, that is ion exchange chromatography. Soon we will start the last chapter, that is thermogravimetric analysis, chapter number 5. Thank you.